All right, here we're going to begin learning about proofs. So there's two styles of proofs that we're going to learn about. We're going to learn about coordinate proofs and then two-column proofs. Right now we're just going to talk about coordinate proofs, which involves just demonstrating what you want to demonstrate using a coordinate plane and some formulas. So it's a solid proof that uses a coordinate plane and algebra to prove geometric properties. Often you're going to need to prove several properties at the same time to complete a proof. So these are the three formulas that we're most going to be using: midpoint, slope, and distance. So when we get into two-column proofs, you're going to really need to worry about each statement being justified by a reason. For coordinate proofs, these formulas are pretty much the reason. So that's what we're going to say. We're going to say by these formulas, we know that this is going to be true. So in the first one, we're trying to prove that the diagonals CA and BD are congruent. So this diagonal, BD or DB, you can say that in either order, is going to be the same length as CA or AC. We're trying to prove that those are congruent or that they're the same length. Another way we could say that is just with this notation, CA with that line over top of it is saying that that's line segment CA, and we're saying that that's congruent to line segment BD. When we say that they're congruent or the same length or the same distance, that's a key piece of information that tells us that we're going to be using the distance formula here. All I'm really going to do is find the distance of each of those. So I'm going to find the distance of CA, or the measurement of CA, and the measurement of BD, using the distance formula for both of them. So it's the square root of x2. So in CA, x2, the x value there is 4, minus x1, which is 0. The x-coordinate of A is 0 squared, plus the difference in their y values, which is 10 minus 0 squared. That was just a substitution step, and now I'm going to simplify all of that. 4 squared and 10 squared together would be 116. So this would simplify to the square root of 116. I could figure out that as a decimal. I could probably simplify it as a radical also, but I don't really need to. I'm just going to leave it like that. I showed the substitution step and then the simplification of that to eventually show that these are going to be the same. I'm going to do the exact same thing for BD. The distance is going to be identical. It's 4 minus 0. It's still that x value of 4 and an x value of 0 squared, plus 0 minus 10. The y value at B is 0. The y value at D is 10. It's going to be the same thing. 4 squared, negative 10 squared. It's still 16 plus 100, which is the square root of 116. That's enough for me to see that those are going to be the same. So I substituted. I simplified a little bit. If you want to keep simplifying, you can, but you don't really need to. We can see that these are the same. So you can show that those are congruent. So I'm going to say by the distance formula, CA is congruent to BD. This is what a coordinate proof looks like. You state your work, you demonstrate your work, and then you say, well, I just showed it. By the distance formula, these have to be the same. All right, on the second one, we are going to prove that E is the midpoint of both diagonals CA and BD. So we want to show that this is the midpoint of both of these diagonals. So I'm going to use that midpoint formula. I'm going to say the midpoint of CA equals, of CA equals something, and then the midpoint of BD equals something, and I'm hoping that those coordinates come out the same. So finding the midpoint is basically just finding the average of both sets of coordinates. 4 plus 0 divided by 2, and 10 plus 0 divided by 2 tell us that the coordinates for CA, for the midpoint of CA, or E, is 2, 5. really similar for BD. 4 plus 0, those are the two x coordinates divided by 2. 0 plus 10, the two y coordinates divided by 2, equals, not surprisingly, 2, 5, which is the same as what we got for the first one. So E, which is 2, 5, is the midpoint of both CA and BD. So I can say by the midpoint formula, E is the midpoint of BD and CA. You demonstrate what you want to demonstrate, and then you say, by that formula, it's clear that I've shown what I need to show. One more. We're going to prove that side PQ is parallel to side SR. We're showing this. PQ is parallel to SR. Those two lines are saying that those two sides are parallel. So I could also say, for example, PS is parallel to QR. One more notation I'm going to point out right now is perpendicular. So I could also say that PQ is perpendicular to QR. PQ is perpendicular to QR. I am going to cover this notation a little bit more in detail, but I just wanted you to be familiar with those two right now. So if we're talking about them being parallel, we could use the slope formula for y2 minus y1 over x2 minus x1 to show that they have the same slope, and they'd have to be parallel. So I'm going to say the slope of PQ equals something. The slope of SR equals something, and hopefully they're the same so that we can show that they're parallel. So this one's a little bit weird. You might have noticed that we have some variables here instead of numbers. Doesn't really change how we solve this problem or how we plug the numbers into that slope formula. I'm thinking about PQ first, so just dealing with P and Q, the slope from that point to that point. We're going to do y2 minus y1 over x2 minus x1. y2 minus y1, which is b, and b over x2 minus x1, which is a and 0. So b minus b on top, that's just 0. A minus 0 on the bottom, that's just a. 0 divided by anything is just 0. So the slope of that line is 0, which should make sense. That's just going flat straight across that graph. I'm going to do the same thing with S and R. y2 minus y1, 0 minus 0, divided by x2 minus x1, which is a minus 0. 0 minus 0 on top, 0. A minus 0 on the bottom, a. 0 divided by anything, still just 0. So, by the slope formula, these two lines have to be parallel. PQ is parallel to SR. Okay, try these three on your own and get them checked before you move on.